Welcome everyone to the session of marketing research and analysis. Today we will discuss about one of the ways of hypothesis testing, which is a very popular method and largely used in all kinds of researchers, be it experimental or non-experimental or quasi experimental like surveys and all. So, wherever you do, but it is largely applied in all cases, right, and the application is much more, has seen much in a larger way in the case of experimental designs especially. So, what is this way of testing, and let us see, and we will discuss about it. Basically, in the last session, if you remember, we had discussed about the beginning of hypothesis testing. We talked about the test of means, right, the test of means in which we and proportions. Okay. So, where we talked about that how do we calculate. Now, we just calculate the z score, which is equal to x bar minus of the population mean. This is the sample mean, this is the population mean, and over the standard error, and we said we would calculate accordingly, and we will find out. And similarly, this holds true for a proportion also, in a case of proportion, right. But this case was only possible when there were two levels, right. That means there were two sample groups, we can say. So, this was the group 1 and this was the group 2, and we could compare it through an independent sample t test, or if the sample was only 1 but taken 2 times, then we said it was the dependent sample t test or paired sample t test. But the question arises what happens when we have more than 2 groups, okay, we have more than 2 groups or more than 2 levels, right. So, in such a condition there is a possibility that the researcher can go for a multiple t test, right. But if you remember, I explained you why, what is the logic behind not doing a multiple t test, and why one should avoid. To do that, in fact, there is something called an Bonferni inequality test, where basically it says that if you do conduct multiple tests, the problem is that the alpha, which we generally take it as 0.01 or 0.05 or whatever it is, this level of alpha goes gets inflated, right. So, to avoid this problem of inflation, so that means if there is a 0.05, that means 5%, and you are having 4 times, so that means it will be around 20% of that means it will get inflated 20%, right. So, this is too much of an loss of information or too much of a type 1 error that is occurring, possibility of a type 1 error. To avoid this situation, Fisher, the founder of this technique, or the one who developed this technique, he came up with a technique other than having the multiple tests, and he said we could do it by studying the variance. So, he said if we could use a Fisher said if we could use the variance, then we can do it better. Now, to do this, he said he calculated something called he developed the F test, or we calculate through that the F ratio, which I had just begun in the last session. So, the F ratio is nothing but I had said it the mean sum of square between, right, divided by mean sum of square within the groups, okay. So, he said if there are n number of groups, right, so you need to find out, calculate the variance for the entire group, right, or you can the total variance, the between the groups, the variance between the groups, let us say there are different teams. So, across the teams what is the variance, and within the teams or within the groups what is the kind of variance. Suppose there are 11 players in the cricket team. So, what is the variance within the team, right. So, when you multiply, when you find out this variance, then you can calculate the F ratio, and by then comparing the F ratio, the calculated F ratio with the table corresponding table value for the F value, then we can say that we want to reject our hypothesis or not. But what is the let us see, let us go by slowly. So, So, what is the definition saying? It says analysis of variance basically involves investigating the effects of one treatment variable. So, this is why I had said this is a basically in any kind of experimental study it is used. So, there is a treatment variable. Now, the treatment variable for an yield, for example, in a agricultural farm is like suppose you are giving fertilizers. So, fertilizers could be the type of fertilizer could be the treatment on an interval scaled dependent variable. Now, that is important. What it says is that the dependent variable and the independent variable. So, the dependent variable, if I remember I had also said this, and the independent variable. Now, the dependent variable in case of a analysis of variance is basically measured in a continuous scale, continuous. So, it may be an interval or ratio scale basically, interval or ratio. Okay. On the other hand, the independent variables are basically nothing but they are the non-parametric, right, in nature, right. They might be categorical in nature, right. So, this is continuous, this is non-continuous or non-parametric, whatever you say. So, this is categorical in nature, right. So, this could be in a form of a nominal scale or something. Okay. So, let us go see. So, what it says to test the differences, the purpose is to test the differences in means for statistical significance. Now, what is the hypothesis? The hypothesis is, suppose there are 4 groups or whatever k number of groups. So, we say there is no difference between the means, that means the means of each group are equal in right. So, mu 1 is equal to mu 2 is equal to mu 3 is equal to mu 4 goes on, right, till mu k. Now, what is my alternative then? The alternative says ki there is at least one mu which is different. So, whichever it is the one we do not know, but at the moment, but at least one is different. That means, I cannot claim that my hypothesis that there is no difference between the means, right, is correct, right. So, it is used when you have one or more independent variables and only one dependent variable. The case ANOVA is basically a one way ANOVA we are saying, we are talking about right now. So, we are having one or more independent variables and one dependent variable. So, let us see, right, what is happening. So, if you can have multiple independent variables, that is one thing. So, multiple independent variables means suppose you have one independent variable, it is a one way ANOVA. If it is a, which is also called as a factor basically, you can understand it as a factor, okay, factor or whatever, one way we say. So, it is a two factor, two way ANOVA, n factor, n way ANOVA, okay. Now, the assumptions, random sampling, subjects are randomly sampled for the purpose of significance testing, it is a random selection, okay. Data is interval level dependent. So, the dependent variable that is in a interval level, so which we also said here, right. Now, this is interesting. In fact, if you remember I had explained ki there is something called a homoscedasticity and a heteroscedasticity. Homoscedasticity means when the data are plotted around the regression line, right, close to the regression line. That means, the variance within the or the standard deviation or the movement of the data from the regression line is minimal, it is quite close, right. But if there is the opposite of that is heteroscedasticity, when the data is highly scattered, right, which is highly unwanted situation, which is not desired. Dependent variables should have the same variance in each category of the independent variable. That means, this test, although it is done, if you go to any software, they measure it through the where the variance is equal, the variance is not equal, two conditions. But generally we take the case of where the variances are equal. That means, if the variances are equal, we would assume then only that these groups can be actually compared, okay. The groups are basically those levels, right. So, this is an example. I will also solve a problem. Let us see one. So, what it is saying, a call center manager wants to know, so if there is a significant difference in the average handle times among 3 different call operators. So, there are 3 different call operators. So, the independent variable are the call operators. So, the call operator could be let us say the independent variable is call variable 1, call variable 2, call variable 3, right. The dependent variable is my average handle time. So, how much of time they are taking to handle the clients customers is my dependent variable. Okay. Now, that means how will it look like? Now, it will look like something let us say. So, let us say this is how it is suppose for the moment. So, we will say let us say this is 40 minutes 40 seconds or this is 20 seconds, this is 30 seconds, this is again 35 seconds. So, whatever the time actually they have taken, right, 42 seconds whatever time seconds minutes, that is up to your unit. So, that is a different story. So, now what you are saying, the hypothesis is that mu 1 is equal to mu 3 because there are 3 operators. So, we are saying the time taken, the average time taken by the first operator is equal to the average time taken by the second operator is equal to the average time taken by the third operator. What is my alternate? As a researcher is sometimes I give an example, a researcher is a fault finder, is generally his habit, an alternative hypothesis through which he finds is generally like fault finding. He is trying to find out how come there can be no difference, there has to be some difference, like he is the Sherlock Holmes, he is like a detective, he is trying to find out. So, at least one mu is different, he is saying. Now, let us see this example. So, the time is given in seconds. So, the operator 1, this is the operator 1's data given to you, operator 2's data is given to you, operator 3's data is given to you. Now, you can understand, suppose you go to an actual folder or a file, right, how the data will look like, how the data will look like. So, you should also understand this. So, this is let us say 1 1 1 1, how many 1 2 3 4 5 6 7 8 9 10. So, 10, right, 4 5 3 4 5 6 7 8 9 10 2 2 2 2 2 2 2 2 till 10 again 10, right, then 3 goes on 10. So, the values are correspondingly. So, in a suppose in any software package you want to use, this is how it will look like. So, the operator, the time, okay, this is how you will you will make, because making in the files also, in the software files also, it is very important how do you put your data, that is why I am showing you. Now, first is what is saying, the let us take the x1. So, there are 3 groups, okay, and there are 10 participants in each group, okay. So, this could be, this is a case where there are equal participation, it is there could be a possibility that there are not equal participation also, okay. So, x1 is equal to 75.1, 74.2 is the x2 and x3 is the 74.7. So, this is the mean of the first group operator, mean of the second operator, the mean of the third operator, right. This is something called, if it is not visible to you, I am drawing it again, the x bar, x double bar is called the grand mean. So, the grand mean is the overall mean, right. So, either you can add up all this till all this and then divided by the number, that is 30 here in this case. So, that means, or you can simply do it by, suppose you have this 75.1 into 10. So, 700.1 into 10 plus 74.5 into 10 plus 74.7 into 10 divided by 30, right. So, if I do this also I can find it, right. So, this is my grand mean, which is coming 74.8. Now, F test is used to determine whether there is more variability in the scores of one sample than in the scores of another sample. Is more variance there in the score of one operator over the other or something. So, let us see now how is using now F. So, the F ratio which I have written here, right, is nothing but the variance between the groups and variance within the groups. So, I said mean sum of square is nothing but the variance we are calculating here between the groups, and this is the within the groups, okay. So, means it is written here mean sum square between, mean sum of square within. So, what is the within group? Let us see the within group, if you can see it is shown here, this is the variances of the observations in each group weighted for the group size. Now, this is important, many a times you will get equal sizes, groups of equal sizes 10 10 10 in this case, there might not be equal sizes. So, if there are not equal sizes, then you have to take into account this factor of group size, this has to be weighted for the group size. If you do not do it, then you will make a wrong analysis. So, whatever the number of groups, so size that has to be taken care of. Okay. Now, this is the between group. Now, between group is this, right, between this and maybe this is another one, right, 3 possibilities. So, the variance of the set of group means from the overall mean of all observations. So, what it is saying, how much is the variance of all the group means from the overall mean of the observations. Now, let me show you here. So, how it will look like, how does it look like. So, I have 3 things, right. I will tell you something, the simplest way is to you do not have to remember anything, right. Find out let us say in this case what is said, it is saying between, right. So, you have the x1 bar, you have the x2 bar, you have the x3 bar, right, and you have something the grand mean, right. So, your between groups is nothing but x1 bar minus the grand mean multiplied by the n1, right. Similarly, x2 bar, so you need a plus, you have to add it up all, right, minus x bar, sorry, here is n2, is it visible? Let me do it again. So, plus n2 into this plus n3 x3 bar minus x bar. So, if you take this, so this is what is the between group, right. So, similarly, the within group is nothing but x1 minus x bar x1 bar, right, square, this is all square, okay, remember please the variance, because this is not a standard deviation, this is a variance which is the square root of the standard deviation, plus x1 let us say x1 for the first row, we are doing only for the first row, right. So, so how will, what will be this? This will be the x11, x21, x31, x41, x51, x61, x7, x8, x9, x10. Similarly, x first row, so the x1 2, x1 3, x1 4, so it goes on, right. Sorry, this is second row, first row, second column. So, 1 2, x 1 2, so this is 2 2. So, x 2 2, x 3 third column, third row 3 2, x 4 2, x 5 2, x 6 2, you have to go on, right. So, this one is third first row. So, this is x 1 3, first row third column, right. So, then is this one, let us say this one, second row third column, right, it goes on till x, this is the third row 10th row, right, x 10 and third column, right. So, it goes on, you have to add it up, right. So, you once you do this, so once you do this, once you are making it, you calculate. So, you have to find it out from the mean of the group in between the group. So, you have done this. This is for the first one, now you are doing it for the individually. So, x1 minus x bar, or just do it for the group, it is simple, x1 minus x bar square plus, let us say this is only for the first, right, first this x2 minus x bar, right, square goes on till x 10 minus x 1 bar square plus for the second. So, x let us say again x 1, the first means this one I am saying, either you do it independently or you write the way I was writing, minus x 2 bar square, it goes on, right. So, you have to find out the within group for all the 3, okay. Now, this is very simple, right. So, you are finding the total, there are 3 things. So, total, now what is total? Now, total is if I am taking the every value, each value minus subtracting it from the grand mean. So, 76.5 minus 74.8, I think it was there, yeah, 74.8. So, 76.5 minus 74.8 square, 76 minus 74.8 and 75.1 again till this one, then starts this one, entire group has to be deducted individually from the grand mean, okay. So, I have calculated this is the total, this is the within, this is the between. So, if I have the total and if I have the within, I need not find the between also, or if I have the total and I have the between, I did not find the within also, because these two will sum up to become automatically this. That means what I am saying is sum of square total is equal to sum of square within plus sum of square between. So, in case you have found the total then and you have found any one of these, the third one you might not also calculate, it is automatically you can deduct it and find out, right. So, this is, suppose this is 22.5 within, it is calculated, and 1.9 is this one. So, what is the total now? Sum of square total will be, so you have to multiply and find out, okay. So, you can say overall is somewhere in between, you cannot do this, yeah, you can just add up, right. So, 22.5, 23.5, 24.4. So, my sum of square total is equal to 24.4, out of which 22.5 is for the within the groups and between is 1.9, okay. So, now let us see what is the mean sum of square. Now, mean sum of square is the sum of square within divided by the degree of freedom. So, I had said now your degree of freedom is equal to the number of elements minus 1, right. So, number of elements minus 1. So, for degree of freedom between the groups you have, let us say this case 3 groups. So, 3 minus 1, right. But when you are doing the within the group, let us say degree of freedom within, there is like it has to be 10. For each column you have to deduct 1. So, 10 minus 1 plus 10 minus 1 plus 10 minus 1, okay. So, that is equivalent to nothing but 27, right, or you could have said n minus k in simple terms, right. So, now the f is coming to, he has calculated. So, this is 0.8, this is 1. So, 1 pi 0.8 is 1.1. So, if you take the f value at the, this is the f value, let us check this. How to check, I will show you. 0.05 level for 2 and 27 degrees of freedom, right, 2 and 27, right. So, did you understand 2 and 27? This is the 2 and this is the 27. So, between is 2 degree of freedom, 27 is the within the group, right. So, now let us go for 2 and 27, 2 and 27. So, this is something here, right, sorry 27 is here, 3.3541, right. So, the value I think it is visible, 3.3541, yes. So, 3.35 would be required to reject the null hypothesis, but what have we got? Now 1.1. So, if we have got 1.1, can we reject the null hypothesis in this case? The null hypothesis, it is coming 3.35, right, and ours is coming 1.1. So, sorry. So, this is, anyway you have to understand, because this is somewhere here and your value is here. So, it is well within the home, it is well within the boundary. So, you cannot reject the null hypothesis in this case, right. There could be some case in which it can cross the boundary, okay. So, this is how the, if you go for an ANOVA table, it sometimes looks like this. Sum of square, if you are using Excel, SPSS something, Minitab or anything, sum of square between the groups is this much, within the groups is this much. So, the total was what I was adding up at that time, 24.4, degree of freedom is 2 and 27. So, total is 29, mean sum of square is 1, 0.8. So, the F ratio is this much. So, we cannot reject the null hypothesis and therefore conclude there is not a statistical significant difference between the average handle time of the operator 1, 2 and 3. At this case we cannot say, but suppose there would have been a difference, suppose let us say there would have been a difference, then we would have said ki at least there is a difference between the mean of first or the second or the third, whatever it is, there is a. To test this, suppose how do you find? Now, to test that we use something called a, although manually we are not doing it, we do something called a, have a post hoc test, please remember this. So, if you go to any, you are using any software package like SPSS or something, then you are using this post hoc test, which basically does nothing but it uses, it calculates the mean, and it uses the mean to find out ki what is the which of them is the most let us say has the highest value and which one has the lowest value, and thus it can tell ki out of this in a significant manner, right, in a significant manner which one is actually the strongest or the highest and which one is the lowest, as good as that, right. So, but now let us say you have a case In ANOVA there is one more important thing that we measure, but I will go to it that later on, this is which is called interaction effects. Okay. But before that, let me also come with okay, let me explain the interaction also. Many a times what happens is there are suppose two levels or two groups, okay, or three groups, right. So, in such a condition what happens that there might be an there are two kind of effects which say, one is the main effect, okay, and there is something called an interaction effect. Now, which is important to study. Suppose there are two things, right. Now, two things individually have an effect on the dependent variable, individually they do have an effect, but what if that when these two things come, which you maybe in English we say in dictionary, if you find the symbiotic or synergy, or sometimes the relationship becomes weak also. So, if two things are coming together, they give a third kind of effect. What is the third effect? The third effect which we say that which happens due to the presence of two different materials, maybe in a chemical lab or in a compound or something. So, we say when these two things come together, automatically let us say, take the example, somebody is enjoying a party, okay. So, when his friends are there, he is enjoying a lot, right. He is also individually, when he goes with a family also, his whole family members also he is enjoying, right. But what if when his family and his friends come together, suppose in the same party, will there be the similar effect? So, in such a condition the interaction comes into play, right. So, that is where one needs to study that interaction effect can have a major bearing on any study. So, if a researcher is doing any kind of study on in a experimental design or anything, they need to conduct the effect of this interaction and show it as a result in the maybe research outcome, research paper, or in their thesis or anywhere, okay. Because interaction has a larger effect in real life than even sometimes the main effects. It is possible, right. Now, we come to a situation where we say there is something called a multiple analysis of variance. Now, earlier you are talking about only one dependent variable and multiple independent variables, right, multiple independent variables you were taking, right. So, 2, 3, 4 whatever. Now, what if I have more than one dependent variable? Let us see this case. Analysis involving the investigation of the main and interaction effects of categorical independent variables, the independent variables are categorical, on multiple dependent interval variables. There are multiple dependent variables. So, if multiple dependent interval variables are there, how would you make the study? So, this is a case where we are talking about basically we say is called the MANOVA. So, there are many many studies, in fact most of people generally do not do this test because they are not aware, but they are not very difficult. At least if you are using any software package, everything is there. If you use suppose SPSS, you will go to the general linear model and you can do an SPSS the MANOVA, which can easily tell you ki when two dependent variables are brought in together at the same time, what will affect how the independent variables will affect them, right. So, to determine if individual categorical independent variables have an effect on a group or related set of interval dependent variables or not. So, this is the purpose. Take an example. We want to make a study where we try to use two different textbooks. So, we are using two different textbooks. So, which are the independent variables, because a change in textbook will affect the change in the dependent variable. So, that is why these are the independent variables. And we are interested in the outcome, which is the students improvements in the math and physics, score, okay. So, in this case that means the maths and physics becomes my two dependent variables, right. We have two dependent variables and score, the score is obviously a continuous variable. So, we are measuring in a continuous rate, somebody is 50, 60, 65, 70 whatever the scores are, and our hypothesis is that both together are affected by the difference in textbooks. So, we are saying that in such conditions the effect of the interaction effect comes into a larger play, right. So, we are saying that let us say that means that these two textbooks are having an impact on the dependent variables, which is the math and physics score. Now, what are the assumptions? The assumptions are the independent variables are categorical, the multiple dependent variables are continuous and interval. Now, continuous and interval, I would have gone to the third case. Third is saying there is a relationship between the dependent variables. So, this is an assumption. So, you just can't put in any dependent variable that you like, no. There has to be a theoretical justification ki why you are using it as a dependent variable and why you are using a MANOVA. If you are feeling that there is a relationship between the two dependent variables, right, A and B, they are dV1 and dV2, then in such a condition MANOVA fits into the situation. Number of observations for each combination of the factor are the same, it is a balanced experiment, right. Now, same example I would just show you how it will look like. The call center manager wants to know if the operator or method of answering calls makes a difference on the average handle time, wait time and the customer satisfaction. Earlier I think we were talking about only the average handle time, right. So, now we have brought in two different things now, the wait time and the customer satisfaction. So, there are three basically dependent variables now, earlier we had only one, right. So, one and this one, are they not related? Yes, they have a relationship, the average handle time, how much of the wait time and finally what is the customer satisfaction, these are the dependent variables. And the independent variables are now only two things, call operator. So, now who is the call operator? Let us say when we give promotions, we find out the person's how effectively he works or how nicely he performs his job. So, how is the call operator performing, let us say in that case, right, and is the method of answering. So, sometimes the call operator might not be the only factor that can affect the dependent variable, the satisfaction and all. So, it could be the method of answering also, how is he answering, is he answering through some other some device which is not very clear, sound is not going well, or some other device or some method which is using which is more clearer and clearer to the customer. So, this is how I am doing. So, my hypothesis now is that average handle time, wait time and customer satisfaction are the same for both the operators 1 and 2. What is the next hypothesis? Null hypothesis. Now, the average AST, W2 and CS are the same whether you have use method 1 or method 2, there are two methods, right. Similarly, the alternative is not the same for operator 1 and 2, the alternative is not the same for the method 1 and 2, right. So, this is how it looks like. So, the total time, waiting time, handle time, waiting time, customer satisfaction, operator 1 and 2, method of answering 1 and 2, right. So, if I am using this method, so here an ANOVA will not fix, okay. The question is then why couldn't you do two ANOVAs, right. You might be asking yourself in your mind, maybe possibly, that why did not I do two ANOVA individually, one taking this group individually one dependent variable then and one of them, and so if I do this also, if you see how many times, how many combinations are coming, each time we are doing, let us say handle time with these two, right, only operator let us say, or handle and method of answering, waiting time again. So, again we are doing the same thing that we were doing in a case of t-test and something, right. So, in such conditions the combinations will increase, and more the combinations or the more the number of ways of doing, more the number of repetitions you are doing again and again individually when you are doing. So, the errors will go on increasing. So, MANOVA becomes a very good techniques. So, this is something I am just showed you, this is something when you do in a software I have brought it, manually I cannot do it now. So, if you do it by this is called something a Wills lambda. If you look at this table and these are the variable 4 and 5, right. So, 4 and 5, okay. Now, if you look at this, now you have to see this significance value. Now, this significance value, I think this is also important for you to know, right. This significance value is the value which helps you to reject or accept a hypothesis. In this condition 0.003 for the variable 4 suggests that the null hypothesis is to be rejected because it is less than 0.05, right, if we have taken 95% confidence, and similarly this also, right. But look at the third one. So, there is an we have taken an interaction between the independent variables 4 and 5. Now, what if I take an interaction effect of operator and the method of answering, right. Now, when I am taking an interaction effect, if you look, now the result is no more significant. So, that means what we are saying, there is a main effect, but there is no interaction effect in this case. We cannot say that there is an interaction effect. It is good if there is no interaction effect, it is good, but what if the interaction effect would have been a very significant one? Then that means we would have said these two things when combined together only do a better job of sometimes, or maybe do an inferior job sometimes, whatever it is, right. So, this is all for analysis of variance and multiple analysis of variance. Thank you.